All right, so it's recording now again. So this part, as I said, I'm just going to give you how to install XGBoost on your Jupyter notebook and then how to use it basically. Okay, it's if you're familiar with sklearn, it's similar, although it's a separate library. It's its own library. XGBoost is not just the algorithm, it's got a lot of optimizations to also run fast, memory management and things like that. So it's actually quite good of a library. Okay. But it's a separate one. It's got its own group of people that support it and everything. All right, so now let's go ahead and start the Jupyter or the environment. Okay, and now we're going to start a Jupyter notebook. And it shouldn't be a lot of code. So we'll have more than enough time to finish before the exam. All right, there we go. So we're going to start a new script. Okay. And I click on new. Python 3. The code is already on GitHub, so you can just get it from there. I'm going to rename this as, remember, I'm just doing this with another data set called Boston, but XGBoost. That's the name of the algorithm. As I said, at some point, I'll reference the paper. All right, so let's go ahead. And again, I'm giving you a toolbox, and this is just another tool. How you use it is up to you, right? And it's up to you guys to figure this out. Maybe you want to combine all these tools somehow. But at the end of the day, I will print out a little trophy, and whoever gets the highest R-square wins that one trophy. Okay. If there's a tie, then you'll have to fight for it. All right, so let's go ahead and install the library. So that should be exclamation pip install XGBoost. Okay, so when I ran this, it gave me an error first, but then when I ran it again, it worked. So hopefully it'll work. Just hit run, and that should be the only library we need to install. Okay. So I'll show you guys how to use it basically. So I think it installed it for me. This is what you should get. So then now we can go ahead and comment it out. And we can go ahead and load our library. So we're going to need XGBoost. So you can just say import XGBoost as XGB, import pandas as PD. Right, I'm gonna try to be consistent in how I've been reading data. So I'm gonna, even though the data will come from the Boston data comes from sklearn, I'm gonna run it into a pandas just to kind of be consistent with our previous example. And then we'll do the example for the wine quality. So then from here, I'm gonna invoke sklearn. I think we had already used sklearn in this environment, so we should have it available. So, sorry?
Import the second line.
Oh, importy. Sounds very Python-y. All right, so let's do from sklearn dot datasets import load Boston. Okay, so we're just gonna, this is just our data set. We're also gonna do train test split. All right, and we obviously need the same R-square score that we've been using for the PyTorch code, right? So that we can compare the same thing. So I'm gonna do from sklearn dot model selection import train test split. So it's the same one that we've used before. And finally, we just want our R-score metrics. So I'm going to do from sklearn dot metrics import R square score. Okay, so it's the same one that we've used before. So now I'm going to go ahead, hit run and load the libraries. Give it a minute, and that's it. Those are the libraries. Actually, XGBoost is pretty easy. It has been made very easy to be used by people. And I encourage you to read up on it for this competition. You know, it might be a smart thing if you really want that 3D printed fancy trophy, to go read the literature, right? So, you know, find out, okay, how did people, you know, on Kaggle win with XGBoost? Because there's a lot of parameters that you can set up. I'm only putting in a few default ones, okay? So use your creativity to win the contents, and then it'll give you an insight into how machine learning works and how people participate in competitions, okay? All right, so let's go ahead and do Boston. That's going to be our data set. And I selected Boston because the score for Boston is, you know, it's a pretty academic data set, so it's going to have a pretty good score. So it gives us an idea that we can get high scores. Obviously, the wine quality data, I'm not doing much with it, so our score will be lower, but hopefully it'll be at least above 40. Okay, so that's kind of what the way I have it set up. Okay, so load Boston. All right, then now we're just going to do our X and Y, as you're familiar with. All right, so kind of following the same approach, our X and Y. So I'm going to use pandas, so pd.data frame. And I'm just going to read in my data from Boston. So I'm just going to say Boston.data, comma, and then the columns are going to be Boston.feature names. Okay, and now we have basically a data frame as we have had before. Then go to Y, pd.series, should be uppercase. And we're going to read in Boston.target. Okay, so this is just how sklearn likes to store its data sets. All right, so now we should have our data. So I'm going to hit run, and it, yeah, usually gives that pink output the first time. Run it again. It's gone. So now we know that we've loaded X and Y. The data is there. Let's print out a little bit of the data similar to what we have done in the past. All right, so I'm going to just do something like just a few lines. X.head, just like that. And you can hit on that one. And you can see it looks like a pandas data frame. It's got our variables there. And that's it. That's it, right? So that's the X data. And then the Y data is obviously in the Y variable. So we could probably repeat that one. I believe it should work. So head for Y. And as you can see, the values are basically there. Any questions? So these are the values that we're going to try to predict. So now let's go ahead and keep going. All right, so now that the next step is obviously we need to do train test split. Now here, remember, when I did random forest in Weka, I did 10-fold cross-validation. That means that I did 10 runs. Every run, I randomized the data differently, and I obtain a value and then kind of average all those 10s. Here, what I'm doing is only one. So, but I already showed you how to change the seed, right? Randomly, so that then you can do different train test splits. So all you have to do is run this 10 times, take a note of all 10 R squares, and then take the average of that, and you'll have something comparable to what you got in Weka. And then you can really compare to random forest, because it could be that the random forest gave us 54. When I run this, it could be that XGBoost with one run gives me 43, but if I run 10, might be 43, 47, 44. You know what I mean? And in the end, it's not 43 out of 10, but closer to 48, 49, and so on. And that's only with like very limited parameters. You need to do some research and see if you can find better parameters for XGBoost. Does that make sense? I'll show you where the parameters should be, but I'm not going to say more than that. And I leave that to you guys for research if you want to win the competition. Got it? Does that make sense? Any questions? Yes, please. Okay, what's your error? All of you are getting that error? Can you use California? I mean, if you can tell me, does it say how to load California? I'll switch to Cal. If for ethical issues, they remove Boston. Is that true? Ethical stuff. Okay, so what does California, is it like load California? But see, here is where I'm reading in Boston. So is there a load California? Because it works for me, I don't know. The other class didn't have issues. Okay. So the two of you, it works. Okay. I'm not sure. Yeah, no. So show of hands if it's not working, guys. Okay, now show of hands if it did work for some of you. Okay. I mean, I don't know this California one. We'll use wine quality in a second. I mean, this was just. Okay, so it's something like, yeah, let's try that. Fetch California. I think I found a command here. Yep. Yeah, I'm gonna try that one. Okay, guys. So I'm gonna try the California one. Follow along if you can. So from sklearn data sets. Import fetch California housing. Okay, let's try this one. All right, no errors. So then let me try, let's call it California, I guess. And we're gonna do fetch California housing. Oops. Okay. None of that. Oh yeah. All right, and I'm going to move these out. Okay, so let me run that. Hey, no errors, or it's loading actually. No, but it loaded correctly. So now let's see if it's California data. Did you guys try this line? With these lines? So California data, California feature names, California target. All right, so let's try that. Okay, so let's run X head. Okay, so we've got some data in there. All right, yeah. So the Y's look different this time around, right? I don't know it's what the Y predicted value is here. But everyone with me, guys? For those of you having problems with Boston? Lucas? Yeah. All right. So either use Boston or California, it doesn't matter. I mean, we just want to see how XGBoost would tackle a data set. Okay. So now we can go ahead and any questions, guys? All right, so this is the part where I'm just gonna give it some simple default values, but probably where you guys need to go in and look and do analysis in the literature, and maybe you're able to get XGBoost to give better performance, okay? So what we have to do is we have the X and the Y's. Oh, and before we do that, I haven't split the data, right? So I didn't do that. So let's do the split. So we need to do X train, X test, comma, Y train, Y test, right? Guys? And so we're gonna do the train test split command. So train test split, and we're gonna give it X, comma, Y, okay? Now here you can play again with the seed, remember, do it 10 times, and also the split, do it consistent with, you know, how Weka does it. So there it's 90%, 10% split. All right, so run this, right? So we got our data sets. Now we're gonna go over here and invoke XGBoost. And as you can see, it's simple enough. We're gonna do XGB dot XGB regressor like that. Okay. That's basically the instantiation of XGBoost. Here, though, is where you guys might be able to figure out some nice parameters to use based on good parameters in competition. I'm just going to give you an example of how it works. So N estimators equal 100, comma, reg lambda, notice it's got parameters that you can change, equal 1, gamma equals 0. So again, need to research it. Max depth. So remember, these are trees. So this implies the number of levels that the tree has. So do you need more, fewer? I don't know, right? Figure it out. That's the challenge. And do a good, you know, and win the competition. All right. So max depth equal 3. And you can add more. All right. So these are just the full parameters to get it to run. All right. So once you do this, and you've done, you know, a good model for XGBoost, you're gonna use it basically. So you need to train it on the data, and that's pretty straightforward. So we're gonna do a regressor dot fit, fit, and we're gonna train it on what? X train, comma, Y train, right? Oops. We just train it on this. Okay, so I'm gonna hit run. and it's training at this time. Yeah, go ahead. You have a question?
What is the significance of lambda and gamma?
Those are the parameters that I said. I'm just putting in default. So they're parameters of the algorithm. And it may be that you need to change them and get a better result. Okay, these are like very basic parameters and may not be the best ones. Okay. Or they may not be as important also. It's like sometimes they're just weights that don't, they may be like, there's a regularization parameter in XGBoost. And if this is 0, the regularization may be 0, for instance. So nothing happens. You know what I mean? So it's like a weight. So play with the parameters. Okay. The performance we're going to get right now, I can tell you right now, won't be 0.54 like we got with a random forest. But XGBoost has been found to be a really good regression tree. So it almost like, should it be better than random forest? It's for you to find out. Okay. Now, if you want to try a random forest, I'll say this is available in sklearn. Okay. So sklearn, although in this class I don't cover sklearn, just be aware sklearn, the thing that we've been using, has a whole bunch of machine learning algorithms, and you can select random forest and also do more experiments. Okay. But at the end of the day, you have all the tools that we've looked at from PyTorch, you have XGBoost, you have the random forest, and maybe you can find other techniques, or like I said, just the objective of the homework assignment is to be the best, to win the competition as measured by getting the highest R-square. Any questions? We had already installed it.
I know, we've already installed one.
Yeah, I don't know. I mean, it should be there. So make sure you have the correct environment. You might be on base, so make sure you activated the environment.
Yeah, no, yeah, that's.
All right, guys, so you can see there's a whole bunch of parameters here that it prints out once the model is done. So again, look at them, play with them, and see if you can figure out ways of improving the model, okay, the performance. So now that's it. As far as training, let's run XGBoost. So we can just do regressor dot predict. And we're going to plug in here X test. Remember that your R square needs to be on next test, right? Always. And run it 10 times, as I showed you before and when we did the PyTorch code. So this is going to give us Y-pred. So now we will have Y-preds and we will have the Y test. And so we can compare them and measure performance. Okay. So we can go ahead and just print Y-pred just to kind of get a feel for the data. So if I look at Y-pred, I see a 1.3, I see a 1, a 0.7, a 3.2. These are also, they seem to be in the same range, so it seems consistent. So that's good. It's a good sign. And then the final part should be to just run the R square. So hopefully with the housing price, I haven't looked at it because I did the Boston one, or this California one, but it's an academic type of a data set, so it should be a high R square, I would assume. So let's do Y test, comma, Y-pred. Yeah, so it's 82. So that's a good R square, right? That's a good R square. But it's now, I only ran it once. Now what you would do is have a random seed, run it 10 times, 82, 85, 87, and find the average. And that you can report that as your score. Got it? Yes, please.
So XGB regressor, did you get none for some of them?
None? Yeah, this one, callbacks. some of these are very, because this has like technical things as well, like using GPU, using memory very efficiently, caching things. So some of these things are more like for performance of the speed and not performance of the R squared. But so, like I said, I mean, there's a lot of parameters with XGBoost, so you'd have to research the literature to get the best model possible. Also, when you report your result, you'll need to, if you say that you got an R square of 60, you got to demonstrate that, right? You're going to come up here and like prove to everyone, right? So that you deserve to win, okay? So just be aware of that. So you need to be able, what I'm saying is, it's not that just getting the value once, but you need to be able to replicate it consistently, okay? Got it? All right, we have 20 minutes, so I'll stop this video and we'll do the last one, which is basically just a